Hello class, today's lesson is 2-7 in your textbook, and we're going to learn how to prove angle pair relationships. So pairs of angles and proving different types of relationships that two angles can have. The first theorem that we're going to write down today is Theorem 2-3, and it's called the right angles congruence theorem. And it's very basic. It just says that all right angles are congruent. Now, the thing that we said about theorems is that we can prove them. So think, how would you prove that two right angles are congruent? All right, I think that this is something that we assume, but let's just see how we would prove it. So here are two pictures, all right, and they both have right angles in them. And what I'm given is that angle 1 and angle 2 are right angles. So in the end, I want to prove that they are congruent to one another. So let's just think logically, what would the steps be to prove that they are congruent? Well, remember, we always start with what we're given. So that's what I'm going to write down. That angle 1 and angle 2 are right angles. Okay, my reason is that it was just simply given in words, and it was also given in the picture. Okay, and my knowledge of right angles is that it's equal to 90 degrees. So I could say that the measure of angle 1 is equal to 90 degrees, and I could also say that the measure of angle 2 is equal to 90 degrees as well. This is simply from the definition of right angles. Okay, well, if angle 1 is equal to 90 degrees and the measure of angle 2 is equal to 90 degrees, then that means that their measures are equal to one another. Measure of angle 1 is equal to the measure of angle 2. This is the transitive property of equality. This is what we've already learned about. And so if the measures of the two angles are equal, then that means that the angles themselves must be congruent. So angle 1 must be congruent to angle 2. And this is the definition of congruent angles. Okay, so in this proof I used two definitions that I have already listed, and then the transitive property of equality, which we've already learned as well. So this is the proof for Theorem 2.3. Okay, so let's move on. Let's do another proof. This time I have kind of a more complicated diagram here. Okay, kind of looks like a step. And what I'm given at the very beginning is line segment AB is perpendicular to BC. That means that they meet at a right angle. And also line segment BC or DC is perpendicular to BC as well. So that's why there's also that little red box to show that they're perpendicular. And what I need to prove is that angle B is congruent to angle C. So we can do this in 3 easy steps. First, I'm going to write down what I'm given. Okay, so I'm going to say AB, that line segment, is perpendicular to BC. And I'm also going to say that DC is perpendicular to BC as well. This is what I was given in the beginning. So starting on our proof should always be pretty simple. You're looking at what you're being given, and then you're working down to how you can reach that conclusion. So I see that both of them are right angles. This is just the definition of perpendicular lines, right? So I could see that angle B is a right angle. And also angle C is a right angle. That's from the definition of perpendicular lines, that they meet at 90 degrees, a right angle. And because of the theorem that we just wrote on right angles, I can assume then that angle B is congruent to angle C, because that's what that theorem says. All right angles are congruent. So we're going to write right angles congruence theorem. I know right now a lot of these names seem rather long, but you're going to get used to them very quickly. Okay, let's add another theorem to a repertoire. This one is theorem 2.4, and it's called the congruent supplements theorem. So I've written the beginning of this theorem already. It says if two angles are supplementary, that's where supplements come from, to the same angle, or to two congruent angles, then they are congruent. Okay, so looking here, I'm really saying, well, I'll just kind of like put a star here. If angle 1 and angle 2 are supplementary, and if angle 3 and angle 2 are also supplementary, then we can conclude that angle 1 is congruent to angle 3. So if I cover up angle 3, we can see that those are supplementary angles. And if I cover up angle 1, angles 2 and 3 are supplementary. So they're both supplementary to that same angle 2. And that means that if they're both supplementary with that same angle, then they themselves must be congruent to one another. So this is theorem 2.4. The next theorem is very similar. It's called the congruent complements theorem. Okay? So instead of supplements, they're complements. So we're going to write down, if two angles are complementary to the same angle, or to congruent angles, then they are congruent. Okay? So I'm going to have a diagram here. You can see that maybe angle 4 and angle 5 are complementary. So we're going to assume that if that's the case, angle 4 and angle 5 are complementary. And if angle 6 and angle 5 are complementary, then we can assume that angle 4 is congruent to angle 6. Okay? So 4 and 5 both add up to 90 degrees, but also if 5 and 6 add up to 90 degrees, then we can conclude that 4 and 6, those two angles, are congruent to one another. All right, here's another postulate. It says, postulate 12, that, well, it's called the linear pair postulate, and it says if two angles form a linear pair, then they are supplementary. Okay, so if they form a linear pair, then that means that they're also supplementary, that they add up to 180 degrees as well. So we can say that if angle 1 and angle 2 form a linear pair, this is in our picture, then angle 1 and angle 2 are supplementary, which means that angle 1 plus the measure of angle 2 must equal 180 degrees. Okay, this is just a postulate. And related to this postulate is our final theorem for today. It's Theorem 2.6, and it's just titled the Vertical Angles Congruence Theorem. And basically it says then that vertical angles are congruent, which means in my diagram here that the vertical angles, so this means, those opposite angles, so angle 1 and angle 3 are congruent to one another. And it also means that angle 2 and angle 4 are congruent to one another.